How much does the Earth curve in 12.4 miles? To calculate the Earth's curvature over a distance of 12.4 miles, we can use the formula for the curvature of a sphere, which approximates the Earth's shape. The Earth's radius is approximately 3,959 miles. The curvature is often expressed as the drop, or the vertical distance from a flat plane, tangent to the Earth's surface over the given distance. Formula for curvature drop. The approximate drop, h, due to Earth's curvature over a distance, d, can be calculated using h equals d22 rh equals \frac d squared 2r. H equals \frac d squared 2r, where h is the drop in miles, d is the distance, 12.4 miles, r is the Earth's radius, 3,959 miles. However, a more commonly used approximation for small distances, accounting for the geometry of the sphere, is h8d2 inches \approx 8 c dot d squared text inches h \approx 8 c dot d squared text inches. This formula gives the drop in inches when d is in miles, derived from the spherical geometry and commonly used for line-of-sight calculations. Calculation. Using the approximation formula h 8 12.4 2 hours \approx 8 c dot 12.4 2 hours \approx 8 c dot 12.42 h8 153.76 hours \approx 8 c dot 153.76 hours \approx 8 c dot 153.76 h1230.08 inches \approx 1230.08 text inches h \approx 1230.08 text inches. Convert inches to feet. 1 foot equals 12 inches. h1230.0812.102.51 feet \approx \frac 1230.0812 \approx 102.51 text h \approx frac 1230.0812 approx 102.51 text. More precise calculation. For a more precise result, we can use the spherical geometry formula. H equals R, 1 minus cos theta. H equals R C dot, 1 cosine theta. H equals R C dot, 1 cosine theta. Where theta equals dr, theta equals frac dr, theta equals frac dr, in radians. Convert 12.4 miles to radians. Theta equals 12.43990.03131 radians. Theta equals frac 12.4, 3,959, approx 0.003131 text radians. Theta equals frac 12.4, 3,959, approx 0.003131 text radians. Calculate the cosine. Cos 0.003131, 0.999951 cosine 0.003131 approx 0.999951 cosine 0.003131 approx 0.99999951. So, h equals 3959, 1 minus 0.9999951. H equals 3,959 c dot 1 to 0.99999951, h equals 3,959 \c dot 1 to 0.9999951. h 3959 0.00049 0.0194 miles \approx 3,959 \c dot 0.0000049 \approx 0.0194 text miles h \approx 3,959 \c dot 0.0000049 approx 0.0194 text miles. Convert miles to feet. 1 mile equals 5,280 feet. h 0.0194528102.43 feet \approx 0.0194 c dot 5,280 approx 102.43 text feet h approx 0.0194 5,280 approx 102.43 text feet. Final answer. The Earth's curvature results in a drop of approximately 102.4 feet over a distance of 12.4 miles. This value represents the vertical distance below a flat plane tangent to the Earth's surface at the starting point. Note that this is an idealized calculation assuming a perfectly spherical Earth, and does not account for local terrain, atmospheric refraction, or other factors that might affect observations in practice. Does this video prove the Earth is flat? The videos claim that the Earth must be flat because a person can be filmed at 12.4 miles, 20,000 meters, despite an expected curvature drop of at least 70 feet, is flawed. Let's break this down. From my previous calculation, the Earth's curvature over 12.4 miles results in a drop of approximately 102.4 feet, not at least 70 feet as claimed. However, the post misinterprets how curvature works in practical observations. Line of sight and elevation. The curvature drop of 102.4 feet is the vertical distance from a flat tangent plane to the Earth's surface. If the camera is elevated, for example on a tripod or held by a person standing, and the person being filmed is also standing, their height above the ground can easily overcome this drop. For example, if the camera is at 5 feet and the person's head is 5 feet above the ground, the line of sight could clear the curvature drop, especially if the terrain is flat or slightly elevated. Atmospheric refraction. Light bends in the atmosphere due to changes in air density, often making distant objects appear higher than they geometrically should. This can reduce the apparent effect of curvature, allowing objects to remain visible over longer distances than expected in a simple geometric model. Misleading expectation. The post assumes the person should be behind the curve and invisible, but this ignores the observer's height and atmospheric effects. On a spherical Earth, you can see objects beyond the horizon if they are tall enough or if refraction helps. For instance, ships disappear bottom first due to curvature, but their masts remain visible longer, consistent with a globe, not a flat plane. Overwhelming evidence for a globe. Countless observations confirm the Earth is a globe, including photos from space, ship disappearances over the horizon, varying constellations by latitude, and the Coriolis effect. Flat Earth claims often rely on misinterpretations of local observations while ignoring broader evidence. Conclusion. This video does not prove the Earth is flat. The ability to film someone at 12.4 miles is consistent with a spherical Earth, when accounting for the observer's height, the person's height, and atmospheric refraction. The claim misapplies the curvature calculation and ignores well-established science. The Earth is an oblate spheroid, as confirmed by extensive evidence. Is the lens really 452x zoom? The claim in the video that a 452x zoom lens was used to capture footage over 12.4 miles, 20,000 meters, warrants scrutiny, especially given the context of the flat Earth argument. Let's examine whether a 452x zoom lens is realistic, and what it would mean in this scenario. Understanding zoom ratios. A zoom ratio, like 452x, refers to the ratio of the longest focal length to the shortest focal length of a zoom lens. For example, a lens with a focal length range of 10 mm to 100 mm has a 10x zoom. 100 divided by 10 equals 10. A 452x zoom would imply an extraordinarily wide range of focal lengths, which is uncommon in practical camera lenses, especially for consumer or even professional video equipment. Investigating the lens. The video claims a 452x zoom lens, but based on available information about high zoom lenses, this seems highly unlikely. For instance, the Canon CJ45X-7B, a professional 4K UHD portable zoom lens used in broadcast applications, for example, wildlife and sports, offers a 45x zoom ratio. This is among the highest zoom ratios for professional lenses, with a focal length range typically around 9.7 mm to 437 mm. 45x equals 437 divided by 9.7. A 452x zoom would require a focal length range far beyond this, potentially something like 10 mm to 4,520 mm, which is not realistic for any known camera lens due to optical design constraints, size, weight, and image quality issues. Consumer cameras, like those with super zoom capabilities, often advertise high zoom ratios, but these are typically in the range of 20x to 83x. For example, the Nikon Coolpix P1000, one of the most powerful super zoom cameras, has a 125x optical zoom, equivalent to a focal length of 24 mm to 3000 mm. Even this is exceptional, and comes with trade-offs like reduced image quality at maximum zoom. A 452x zoom would imply a focal length range far beyond anything currently available, likely exceeding 10,000 mm at the telephoto end, which would be impractical for filming due to atmospheric distortion, camera shake, and the need for an extremely stable setup. Digital zoom misrepresentation. The 452x zoom claim might stem from a misrepresentation of digital zoom rather than optical zoom. Optical zoom involves physically adjusting the lens elements to magnify the image, preserving quality. Digital zoom, on the other hand, crops and enlarges the image digitally, often leading to significant quality loss. Some consumer cameras or smartphones advertise combined zoom ratios, optical plus digital, that sound impressive but are misleading. For example, a camera with 50x optical zoom might advertise 500x zoom by including digital zoom, but the actual usable magnification for clear footage would be much lower. A 452x zoom in this context could be a marketing exaggeration, not a true optical zoom. Practicality for the video's context. The video claims to film a person at 12.4 miles, 20,000 meters, using a 452x zoom lens. To assess this, let's consider what focal length would be needed to capture a person at that distance. The angular field of view, FOV, of a lens depends on its focal length and the camera sensor size. For a rough estimate, a person 6 feet tall, 1.8 meters, at 20,000 meters, subtends an angle of approximately tan minus 1, 1.8 20,000, 0.0052 tan, to the power of minus 1, 1.8 20,000, approx 0.052 circ, tan, to the power of minus 1, 1.8 20,000, approx 0.052 circ. To make the person fill a significant portion of the frame, for example, 1/3 of the vertical FOV, the lens's vertical FOV would need to be around 0.0156 degrees, 3 times the person's angular size. For a typical 2/3 sensor, common in professional video cameras, with a vertical height of 6 mm, The focal length f required for a vertical FOV of 0.0156 degrees is FOV, radians, sensor height, \text, FOV, radians, \approx, \frac, \text sensor height f, \text, FOV, radians, \approx, \frac, \text sensor height of 0.0156 times pi 180, 0.00272 radians, 0.0156 caret, \circ, times, \frac, pi 180, \approx, 0.000272, \text, radians, 0.0156 caret, \circ, times, \frac, pi 180, \approx, 0.000272, \text radians, f6, 0.272, 22.059, mmf, \approx, \frac 6, \text m, 0.000272, \approx 22,059, \text m, f, \approx, \frac 6, \text m, 0.000272, \approx 22,059, \text m. A 22,000 mm focal length is far beyond the capability of any practical zoom lens, even the Nikon P1000's 3,000 mm. Professional telephoto lenses used in astronomy or surveillance might reach such focal lengths, but they are fixed, not zoom lenses, extremely large, and require specialized setups, not something you'd use handheld or in a casual filming scenario as implied by the video. If the lens were a 45x zoom lens, like the Canon CJ45 x9.7b, with a maximum focal length of 437 mm, the FOV would be much wider, and the person at 20,000 meters would appear tiny in the frame, likely just a few pixels tall, making it difficult to identify them clearly without significant digital zoom or cropping, which the video might have used to exaggerate the effect. Conclusion: the claim of a 452x zoom lens is almost certainly inaccurate or misleading. No known optical zoom lens achieves such a ratio. The highest practical zoom ratios are around 125x, for example, Nikon P1000, and professional broadcast lenses like the Canon CJ45 x9.7b offer 45x. The 452x figure might be a misrepresentation of combined optical and digital zoom, or an outright fabrication to bolster the video's flat Earth claim. In reality, filming a person at 12.4 miles would require an extremely long focal length, for example, 22,000 mm, far beyond what a 452x zoom lens could achieve, and would likely involve significant digital enhancement to make the subject visible. The lens used in the video was likely not a 452x zoom, and the claim does not hold up under scrutiny. 15 web pages.